Yeah, so we're starting week 6 today, starting with logic, and we're going to be looking at conditional logic. So I'm going to probably use the console a little bit in this example. So I'm going to go ahead and open this up. And then I'll also probably want to do some examples in P5. So let me open up a editor window as well, just so I can have that available. And then we'll get started. So we're talking about conditional logic. And conditional logic falls under a broader category of programming concepts called control flow. So I won't really talk about that in the lecture today, but actually if you look at um, the, the schedule for this week, there's a Code Academy link to a lesson on control flow. So again, this is like a non-required this is not a required assignment, but this is a good thing to kind of use to review if you're confused about how conditionals work. After we go over it today, this is a good place to review this kind of interactive lesson. So this falls into a more broad category of programming called control flow, which is basically like how do we make our program do different things at different times and kind of make decisions about what happens in the program. So yeah, that's the main thing that we're talking about when we talk about logic is making decisions. So we're designing a program and there's all these different points where a user may do one thing or another, or we may want one thing to happen based on a certain set of parameters or conditions. And so we have to have our code make some conditions or make some decisions. And so in order for that to work, we have to come up with a way to kind of formulate that decision. So the way that we do that is we create conditions to simplify the different possibilities. So for a really, really simple example, if we're trying to make a decision about what we're going to wear on a basic given day, we may formulate that decision as a binary, a if a yes or no question. So we might say, should I wear a jacket? Well, what's the condition? The condition is if it's cold outside, then I do want to wear a jacket. And if it's not cold outside, then I'm not going to wear a jacket. So, you know, getting dressed for the day might involve tons of little decisions like this. But and it ends up with this, very complex output where we have lots of different types of different articles of clothing that we have to arrange in a way that makes sense for the weather, as well as, hopefully looks good and is appropriate for the setting that we're in. And, there's various other considerations. And so we want to take all that complexity and try to figure out where we can boil it down to simple questions that have a yes or no answer. And that way we can use basic logic, which the computer is really good at, to make those decisions. So again, is it cold outside? Then I'll wear a jacket. And then eventually, if it's not cold outside, then we have a series of other choices and conditions to create. So we call these decisions conditional statements. So a conditional statement is something that is going to be either true or false. We also looked earlier in the semester at that type of data, which is a Boolean. So a conditional statement is a statement that resolves to become a Boolean value. So Boolean values, let me go over here for a second. So a Boolean value is either true, that's like a keyword in JavaScript, or false. And we can assign those values to variables. So I can say variable x equals true, and then that will allow me to ask questions that depend on the condition of x. So conditional statements and Booleans kind of go together, and we'll see some examples of that. So yeah, as we were just saying, Boolean is a data type that's either going to be true or false. In JavaScript, one thing that's kind of nice but also a little confusing is that certain things can evaluate to be true or false. We call this like being truthy or falsy. So truthy or falsy, which is basically just a way of saying that like a number usually, if I have a number like variable x equals 100, that isn't strictly true or false, it's just a number, 100. But actually in JavaScript, this is a truthy value because if I do a condition with x, it's going to resolve to be true. And if I do a condition with 100, it's going to resolve to be true. And so that's just a convenient way to kind of like check our data sometimes, check to make sure it exists or that it has a truthy or falsy value. But it can also lead to some confusion where things that you would normally not use as a true or false value could still work as a true or false value. Um, we hopefully won't really run into that in our kind of early lessons on logic. So we don't really have to worry about this a whole ton, but just something to be aware of. So what we really will be doing to evaluate our conditions most of the time is using an if statement. If is a keyword sort of like var or function. In JavaScript, if is the beginning of a conditional statement. And it actually looks quite a bit like something that we've seen before in class, which is a function. A function is also something that does control flow within a program, but it's a little bit different than a condition. But one thing that's kind of similar with the function and a condition is this basic setup where we have a keyword and then we have some parentheses here and then we have some curly brackets here. And so we can ignore this part for a second, but what I want to look at is the curly brackets. The curly brackets define what code is part of this function. And we'll use the same syntax to define what is part of our conditional code. Um, so in this case, we're going to say if, and then we're going to have some condition that says, should we wear a jacket? Um, so we might have a variable like, is cold. And if it's true, then we might want to wear a jacket. So we might have a function wear jacket, and I spelled that wrong. For now, we'll just say I'm wearing a jacket. And so we might say if, and here's where our condition goes, is cold, then we want to wear a jacket. So we'll call that function. And this part won't really make sense quite yet because we haven't really gone into functions, but we'll go over that soon. So, if it's cold, then we're going to be wearing a jacket. And then if, the day passes and is cold turns to false, and we run our code again, then whoops, here it is. Now, since is cold is false, this conditional statement will resolve to false, and so we'll just ignore this code. So you'll see when I run this, now there's this undefined return, but nothing happens. We don't get to wear a jacket because it's not cold. And so we'll look at how that looks in P5. So we're going to start with this value mouse is pressed. And this is a system variable, so it's similar to mouse X and mouse Y, but it's only either true or false. It's a Boolean value. So it doesn't have a number like the position of mouse X. It just is true or false depending on whether or not we're currently clicking the mouse button. So let's take a look at this example here. We can just read this code. So right now, our mouse's press value is false. I'm not pressing the mouse. You can't see my mouse, but I can tell you that I'm not pressing it. And then if I do click the mouse, we can see that the background is changing to be this plum color. And as soon as I release the mouse, it's no longer the plum color. So here's our conditional statement. It looks very similar to what I just wrote. Let's write this up in our editor so we can see what this looks like. So we need a draw function here. If we just have setup, it's just going to run once, so we won't be able to see that condition change. So let's just write a simple version of this condition. So let's say if mouse is pressed, then we're going to draw the background plum. And what we want to do actually is move this background up, because what we're going to do is overwrite the first background if this condition is true. So I'm going to run this sketch, and you can see that the background is gray. And then when I click the mouse, now the background is plum. So this is kind of similar to the interaction stuff that we did a couple of weeks ago, where it's just kind of arbitrary, the fact that we're changing the background color and we're pressing the mouse. These are just arbitrary things that we're choosing to show this example. But what we really want to look at is just how did we make this decision? So we use if to say that we're starting a condition, And then inside the parentheses, we have this conditional value. And mouse's press is either true or false. It can't be anything else. So this is either going to be true or false. And then if it's true, we run the code that's inside of the two brackets that follow. If it's not true, then we don't. And we can put as much code as we want to in here. If I want to also draw an ellipse at 50-50, it will do that too. So there's my ellipse, but it doesn't show up if I'm not drawing. So we can put as much code as we want to in between these two brackets, and it will only occur when this condition is met. Um, so mouse is pressed when it's true. Let's log mouse is pressed here so we can see. So mouse is pressed is false as long as I'm not pressing the mouse. And as soon as I start pressing the mouse, it becomes true. And so we run that extra bit of code. So that's the basic idea. Let's see some more examples. So besides just testing whether something is true or not, like mouse is pressed, we can also evaluate conditions that are a little bit more complex. And to evaluate a condition, we use what's called a comparison operator. And this is going to look like a little bit like some algebra or some basic math. So there's a few different types of operators. Most of these operators we will not really be using. Well, actually, we'll probably see a lot of these operators by the end of the semester. But they allow us to evaluate different types of conditions, so we can make more complicated decisions rather than just is the mouse pressed or not. So, we could say if the mouse is pressed, but we could also want to know, am I pressing the left button or the right button? So that's a separate condition that we need to have to add on to our first condition of whether the mouse is pressed. But there are multiple buttons that could be pressed. Similar with the key. So if I change this to if key is pressed, I'll get the same result, except I can use the keyboard now. So now I'm hitting space, but I can also hit any key. And so what we want to be able to do is test not only if the key is pressed, but if it matches a certain key. So we need to use more logic to add to those conditions. So let's go through the basic operators, and then we'll add them into a P5 sketch. Either one. I don't know if we get to it. Let me see. Do we get to this? I don't think we get to it in this lesson, but I'll go over it in a minute. Yeah, this is all mouse X, mouse Y stuff, but uh, I'll show that in a second. Okay, so in JavaScript, two equal signs, this is the one that's going to trip up people the most, is that two equal signs is how you compare two values. And so we'll use the keyboard example in a second, but I'll just do it in the console first. So if I want to compare two values, um, it's a double equal sign. So when we use a single equal sign, we might say something like variable x equals 1. And as we talked about with variables, this single equals is really an assignment operator. It's not a conditional operator. Even though it looks like in math when we're comparing two values, it's actually an assignment operator, which is a different thing. It's sort of like that, but it's not even like I wouldn't even put equal in this sentence. I would say like x gets 1 because x is just an abstraction. X is just a name. A name doesn't have a value, it points to a value. So a value is like 1 or 2 or the string hello or something like that. But a value can be compared to things, but x is actually just like referencing a value. So it's kind of a hard thing to get at first. But eventually it'll kind of make sense. So let's use this. So we have variable x equals 1. I'll leave that there because we'll compare it in a second. So if I want to say 1 double equals 1, that's going to be true. So the value 1 is equal to the value 1. If I say 1 double equals 2, that's going to be false. The value 1 does not equal the value 2. So when I say something like x double equals 1, this is going to be true not because x is necessarily the value 1, but x points to a piece of memory which is currently the value 1. So x equals 1 is true and x equals 2 is false, but x could change. We could set x to 2 and suddenly x equals 1 is false and x equals 2 is true. So variables do make it a little bit confusing, but just remember that x is not a number, it's a name that points to a number. So we have the double operator. In JavaScript, you'll also see things that look like this, x triple equals 2. What this means is that the value and the type are the same, and this is a safer operator to use. It's a little annoying because it's like 3 equal signs, but this is a safer operator to use than just the double equal sign. So you'll see that in a lot of examples. I'll give you an example right now. If I say the string 7 double equals 7, JavaScript actually is going to tell me this is true because even though this is a string, it's looking at this number, the string, and saying, okay, there is a number in there. So is that number 7? Actually, it is. So JavaScript is actually doing a little bit of extra work for me here. But if I said 7, the string, triple equals 7, the number, that's actually going to be false. It's a little bit in the weeds, but it's something that you'll see is like, what is this triple equal sign? That's what it's doing. And what it's really doing is it's, first of all, it's comparing the type. So it's saying type of string 7 is string. Type of the number 7 is number. So if I ask type of the string 7, is that equal to type of the number 7? That's going to be false whether I use 2 or 3 equal signs, either way, because the type of 7 is actually a string that says string, and the type of the number 7 is actually a string that says number. So it's a little confusing. You probably won't run into this too much, but just so you're aware, there is a sort of triple equal sign operator in JavaScript. So we have the double equal sign operator, and that will tell us if something is true. So true equals true, 1 equals 1, false equals false. This is actually true because they're the same value. Hello equals hello, et cetera, et cetera. So if two values or variables have the same data, the same value, then we'll get true using the double equal sign. Where it gets confusing is we also might want to know if something's not true. We might want to know if x is not equal to 3. That might be something we would want to know if we're checking. We only want to use numbers that are not 3. That actually is true. So even though x is 2, we can say, is x not equal to 3? That's what this exclamation point means. In this case, and a lot of other cases in programming as well, it means the opposite. So is x not equal to 3? Yes, x is not equal to 3. So we can get a true value from two values that are not the same. So that one's a little confusing. We probably won't use that a ton, but you may see that in some JavaScript examples. So then the other operators that we see here are really for comparing number values, not comparing other types of values. And these are just like greater than, less than, like things that, numbers that can be bigger or less than other numbers. So if I say x is greater than 0, that's going to be true because x is 2. 2 is greater than 0. We can also say x is greater than or equal to. So if I say x is greater than or equal to 2, that's also going to be true because x is 2, whereas 3 is greater than or equal to 2 is also going to be true. So just greater than or equal to, you probably remember that from math. And then the opposite of those, less than and less than equal to. So x is less than 2, that's going to be false because x is 2. X is less than or equal to 2 will be true. 0 is less than 1, that's going to be true. 0 is less than 0, that's going to be false. So this is going to be more important when we get into loops in a couple of weeks. We'll use more of these type of comparison operators, but we may see some examples of that in our code as well. So yeah, we're going to use some examples of that. I'm going to do an example with that Ben was asking about is how do we know what key is pressed? I'll just show that real quick, and then it kind of relates to some other things that we're going to do. So if I go to the P5 reference, and this is under events, so there's key and key code. So key is pressed is true or false. Key is what key has been pressed, and the values are just the letters or numbers of the keyboard. It actually doesn't have a list here. And then the key code is the code that's associated with each key. So like for the space key, um, let's see, there's backspace, delete, enter, return, tab, escape, shift, control, option. Huh, there's no space key. That's weird. But if we want to know what the key values are, there's a good website for this, which is keycode.info. And these don't necessarily match. Some of these, the thing that's annoying is that these don't always match P5, but most of them are the same. So like for the space bar, the key code is 32. That's the safest one to use. There's other things like event.code is space. Um, it actually doesn't have an event key. So that's a good example of sometimes it doesn't have everything. So like space is 32, A is 65, B is 66, C is 67. And so each key on the keyboard is mapped to a number on the computer. And this value, event.which, will tell you what it is, but this also gets stored in the key code in P5. So like enter is 13. There's probably a chart somewhere. Oh yeah, here's a table. This shows you all the code, the keys and their corresponding codes on the computer. And this is for ASCII values. There's different standards for this, but pretty much everything that you would use is going to use this ASCII standard. So you can see that there's like some modifier keys and stuff here. And then as we go lower, all the digits are between 48 and 57. Then there's some punctuation. Here's the lowercase letters, um, some more modifier keys. This is a numpad if you have like one of those square number pads on your keyboard. Function keys, um, other stuff like audio, media keys, more punctuation. So yeah, those are all the kind of keys that map. And so what you could ask instead of key is pressed is we could actually do a comparison here. We could say if key code equals 32, so we're using a comparison operator. Key code is a variable, but like X, it can change, and it will change to match whatever key we press. So if the key code is 32, let's change the background to blue. Okay, so now if I press any key, it's going to be plum. But if I press the space bar, then it's going to become blue. And there's a little bit of a different behavior here because if key is pressed, it's just true or false if I have the actual key down. So right now I'm holding A, and we see that the purple background, the plum background. If I hold B, we get the same thing. But if I hold space, it turns blue, and then I've actually released the space bar, but it stays blue because we've changed the key code to 32, and it's going to stay that value until I hit some other key. And then that's why we see like a little bit of a flash of the purple when I switch from key code to key is pressed. So that's how we can use a comparison operator in an actual sketch with the key code. You can also use key, but there isn't one for space, so it would have to be like one of the letters or numbers. So we can also use conditional statements to look at the position of the mouse or other parts of our sketch inside the canvas. So I'm going to compare the position of the mouse to this value width over 2, half the width of the canvas right here. So this is the condition up here. So I'm saying if the value of the mouse X, is greater than half of the value of the canvas, so half the width of the canvas. And so you can see I'm printing out these values here. So you can see as I move mouse towards the left side of the canvas, it gets smaller and smaller. So this is the 0 on the x-axis all the way at the left. And if I go all the way across the mouse, eventually I get to the other side. This one happens to be 640. And then in the middle of that, width over 2, is that 320. And so we can see as soon as the value of the mouse x gets to be larger than 320, then we see this code run, which is drawing this ellipse in the middle of the screen. So we're mapping this to a physical space, but that's just to show for this example. It doesn't, that's not typically how you would always use this. So let's move on to else. So else is a way to deal with what happens if the if statement isn't true. And you can imagine, this when we go back to our original question of if it's cold outside, should I wear a jacket? If the answer is no, then you're not going to wear a jacket, but you might do something else. You might wear a sweater or a dress or a different type of t-shirt. There might be other questions that you have to ask once you get past the first condition. So in this case, we're sticking with the same mouse condition and we're drawing an ellipse. And if we're not hitting that condition, then we're going to draw a rectangle. So you can ignore all this stuff down here. This is just the display stuff, but the main code is right here. So we have our first if statement and we have our condition here. And then we have our code block. So here's the beginning of our code block, and that's our code. We draw an ellipse, and then that's the end of our first code block here. And so if we want to do something else, if the if statement is false, that's when we go to this else block. So we just say else here after the if statement is done. And this has to come right after. I can't do something like var x equals 1 here. That will break this code. So the else statement has to come right after the end of the if statement. It doesn't have to be on the same line, but that's usually how you'll see it written. It could come on the next line. Sometimes people also write these statements like this. This is more of a C++ type style, but some people do this in JavaScript where you have the condition and then you have the code block written like this, but I usually don't do that. Anyway, so it doesn't matter where it is exactly as long as it comes directly after this else block, or sorry, the if block. We have the else block, and for this case, we're going to draw a rectangle. So when we run this code, as long as the condition is false over here, we see a rectangle, and when we cross over, we see our circle. So let's put that in here. So we have if the key code is 32, let's draw the background. So now let's say else, and in this case, we can draw a background. Let's draw a background is red. And what this will do is it's going to ignore all the rest of this code up here. So let's just delete it for now. So if the key code is 32, it'll be blue. But right now, the key code is not 32. I haven't pressed space, so it's red. If I hit space, now it's blue. And if I hit a different key, it's always going to be red because everything that's not 32 gets caught in this else block here. So anything that's not 32 is else, and therefore the background is red. Let's take a look at what the key code is. So I'm going to just draw the key code directly onto the screen. So let's put it at 2020, and let's make it a little bit bigger. Okay, let's put it down a bit. Okay, so you can see the key code starts at 0. There's no value there. And then when I hit the key space, it changes to 32. So we get our blue background. And if I hit A, that's 65, B is 66, C is 67. Whatever key is not 32, that's going to give us this else block down here. So let's continue. Was there a question? I think yeah. I'll show you how to do that we're gonna get to an example that will do that in a second, but I actually have never tried setting key code directly. Let's see what happens if we say key code equals 0. Okay, so it does seem to kind of work. Actually, let's go here. So let's say if code, no, that's not going to work. Let's do it here. Uh, no. Yeah, there's not a good way to do this, but that's not really how key code should be used, but I'll show you how to do that in a second. There's a couple different ways to do it. Okay, so we have this basically the exact same example, except in here I'm using mouses pressed rather than the key code, but it's pretty much the same thing. If the mouse is pressed, we draw the plum, else we draw the light blue. Um, so so we're gonna go over one more thing, and then we'll do what Ben you're talking about, which is a compound conditional. So we have if, we have else, and then obviously some decisions are more than just either or. So if we have more than two possible outcomes, we can use else if. Ben, I can hear your keyboard if you don't mind. No worries. Okay, so else if is if we have more conditions, and we can actually have as many conditions as we want and as many else ifs as we want. We can only have one if and one else, but we can put as many else ifs in between as we want to. So in this case, we have a more complicated question. If it's snowing, I'll wear a heavy coat. If it's raining, I'll wear a raincoat. Otherwise, I'll wear a jacket. So we have an original if it's snowing, and a something to do if that's true. We have a second if, our first, which is else if, then we have what we're going to do then, and then we have a catch-all for else. Everything else is we're going to wear a jacket. Um, so in this example, what we're doing is we're dividing this vertical space into three sections. And if our mouse is in one of those sections, then we're going to draw a light. And this kind of looks like a little stoplight. So it could be stop, uh, slow down, or go, or red, yellow, green. And so what we're doing here is we're comparing these values. Um, and I want to actually, let's code this up because I want to show you where you could go wrong with this when it comes to this type of condition. So I'm going to do a different sketch for this one. And so we're going to start with our first condition for our stoplight. So if mouse y is less than, let's see, our canvas is 400. So let's do something that's easily divisible by 3 so I don't have to do a lot of math. So if our mouse is less than 100, we'll draw the red light. So we're going to say fill is red, and we'll draw an ellipse. And let's put it in the middle of our canvas, so 200x, and we'll put it kind of in the middle of the top area, and we'll make it 100 pixels wide. And there we go. So there's our stoplight. So you can see if my mouse Y goes above this 100, so the value is between 0 and 100, then we're going to draw this red light. So here's why we want to use an else if. I'm going to show what would work, what would happen if we just use two if statements here. If I said if mouse Y is less than 200, so this will be my next statement. This is going to be the yellow light, so we'll say fill yellow, and ellipse is 200x again. We're going to move up, so I'm going to say 50 plus 100, and 100 for the y. Okay, so notice now that both of these conditions are true if my mouse is in the middle. Because if my mouse is in the middle of the screen, it's obviously also, or sorry, other way around. If my mouse is less than 100, then we see both the red and the yellow light. Because obviously if my mouse is less than 100, it's also going to be less than 200. So we only want to see one light at a time. So we have to change our conditions. There's different ways to do this, but one way to do it is to add in an else here. And so now, instead of reading both of these conditions, if mouse y is less than 100 and if mouse y is less than 200, it's going to read this condition first, And then if that condition is false, that's when it goes on to the next condition. So if this condition is true, we never even look at this one. So that's how we can separate these conditions. So now we have red, yellow, and nothing down here. So now we can actually just write else to do our last bit. We can fill green and do an ellipse at 200x, 50 plus 200y, and 100 size. And now we get red, yellow, green. So why can we do else here when we just had to have conditions here? This is because we understand the context. We know that if the mouse is less than 100, and it's if we know that if mouse y is less than 100, if that's false, we know that we're not in this top part of the screen. If mouse y is less than 200 is false, we know we're not in here. And so the only other possibility in this case is that we're at the bottom. If there were further possibilities, then we'd have to add an else if here. But since they're not, since we know that the only other possibility is this bottom part, then we can just use else here. But this would work just as well if I said else if mouse y is less than 300. It would do exactly the same thing. It's just unnecessary. Okay, so one thing I do want to show you guys is if I get these out of order. So you might think, okay, if y is, less than 100, if y is less than 200, you know, there's a reason why I started with less than 100 because we need to do this in order. If they were out of order, so let's say I moved, I'm gonna put these like this for a second so it's easier to see. So let's say I did this out of order and I started with green. So I'm going to move my green statement up to the top. And I'm just going to change this to a regular if. And I'm going to change my red to an else. So now what happens? There's only the green value. So why is this happening? So my mouse Y is always less than 300, regardless of where it is on the canvas, because 300 is the absolute bottom of the canvas. Of course, if I go below the canvas, then it's not true. So because we checked this statement first and this statement was true, we never make it to these second two statements because of the else here. So these just get completely ignored because the condition that satisfies the stoplight is also satisfied by the green light down here. So we do have to be careful that we're going in the right order. If we're using less than, then the numbers have to be getting larger. If we're using greater than, then it would all flip around. So if I said instead mouse Y is greater than 200, now we see green, red, yellow. Because now if this is true, we know that we're greater than 200, but we don't know anything else, right? We don't know if we're less than 200. So now this works again because we've changed the orientation. So it's a little bit confusing because it's a combination of the orientation of the condition that we're asking and the order that the values go in. So there's no one right way to do it. I usually start with a lower number and go up, but it doesn't really matter how you do it. You just have to be aware that you have to kind of match those conditions. Okay, let's go back here. I'm going to skip that for now. It's not really necessary. Okay, so this is a tricky thing that you'll run into. This is really, I should put this at the end because this is something I just want to go over in case you see this in examples. So I usually will not write my code like this, but if you look at examples of code online, you'll occasionally run into if statements that look like this. If x equals 1, then console.log hello. So you'll occasionally run into statements that don't have any brackets. And this didn't run because I guess I must have reloaded. Oh no, I changed x to 2. So let's change x to 2. There we go. So this statement actually ran even though there's no curly brackets. And that's fine. That's something that is true in JavaScript and a lot of other languages. If you have a single line condition, then you can not use the curly brackets and it'll understand what's going on. I tend not to do this because it can be confusing to read, but it can also lead to actual problems in the code. So let's take a look at this example. So if true, alert, this works. So this is one condition with no curly brackets. And this is going to work because it reads this as one statement. It basically says, if true, alert, this works, and there's the semicolon at the end. It's just one statement, and it runs the code, and it's fine. You can also do this with if else. So if false, this will not run, else this also works. So there we go. We see this also works. And so you can do this with if else and else if as well. You can have a bunch of statements that don't have curly brackets. You can save a little space with this if you want to, but you'll run into a problem here. So when you read this code, you're going to say, if false, this should not run. And then it'll look like, well, I'm still inside of this if false condition. So this second line shouldn't run either, right? But that's where you run into an issue, is that if we don't have a curly bracket to say how long this statement goes for, then it's just going to end after the first statement. We're not going to get to this second statement, its own statement. So in this case, uh, the first statement doesn't run because the condition says if false, but the second statement does run because we're done with the condition at that point. So you don't really have to worry about this. This is just something to be aware of, because if you're looking at examples online, you will see in JavaScript conditions like this where you have an if statement with no curly brackets. But I'm not going to write code like that, and I don't recommend that you write code like that. So you generally don't have to worry about it. Okay, let's get to our last bit, which is making more complex decisions. There's two ways to do this. One is a nested if statement. And this is one way that we can solve the question that Ben was asking. So we can actually put an if statement inside of another if statement. And we can do this as many times as we need to get our code to work. So in this example, I'm checking to see if the mouse is pressed first, and then I'm looking at whether the mouse is on the right side of the canvas, mouse X is greater than width over 2, or if it's not, then I'm going to draw a rectangle. So if I'm not doing anything, there's nothing on the screen. If I click, then I see a shape, and if I move my mouse to the right, then I see the circle. So there's two different conditions, and there's three possibilities. There's no shape, there's circle, and there's rectangle. So that is a nested condition. Nested just means something is inside something else. Like you can think like a bird's nest. So if I fold up this code, we can see that, this condition, uh, this thing is kind of slow. Whoops. Uh-oh, I guess it just doesn't work. There we go. Okay, so we can see that this block of code is nested inside of this block of code. So that's why I can collapse this if it works, which it doesn't. There we go. Okay. So yeah, nested just means it's inside something else. Okay, so let's use that approach to solve what Ben was asking for. So right now I'm just asking if the key code is 32, then I want a blue background. But the problem with this is that even when we're not pressing space, the background stays blue because the key code is still 32. So what I can do is I can nest this entire statement inside of a different condition to ask if the key is pressed. So I can say if parentheses key is pressed, and then I want to make sure to indent everything in here because it's inside of a new code block. And then I put the parentheses down there at the bottom. And now we can see there's actually no background because I'm not drawing a background at the beginning. And now if I hit the space key, I have to click on the canvas first because it doesn't have focus. If I hit the space key, actually the blue is still there. So we do need to draw some background. So let's do an else over here. Actually, let's just draw a background first because we don't want to get too crazy. Let's draw a background that's gray. Okay. So if I hold space, now I see my blue background. And if I let go, the key code is still 32, but this first condition is no longer true. The key is not pressed. And so then I'm actually never going to get this else here because there's no circumstance in which a key is pressed. Oh wait, no, I can. If I hit A, sorry, I can get this. So if I hit A, the key is pressed, but it's not key code 32, so we get this red background. So I can add conditional statements. I can put conditional statements inside of conditional statements. They can have their own if and else if, and I can do things like another else down here. I won't. You can the conditional statements can get to be pretty crazy. Generally, you don't want to do something like this if it's hard to read, but if this is the easiest way to do it, then this is fine. But usually, if you have an if statement, instead of opening a bunch of other if statements inside of that if statement, you might turn this into a function like draw a background or something like that. But we haven't actually talked about functions much yet, so let's save that for later. Okay, so that's one way to do it. This is a nested if statement. The other way to do it is using a compound statement. So this is the last little bit that we'll talk about, and yeah, this is probably a lot of information, but hopefully it makes sense. It all relates to each other. So if we have a more complex question, then what's the key code? If we want to ask what's the key code and if the key is pressed at the same time, we can nest our if statements or we can add them together, and we can actually do this using and or. So we can actually say and or if something is true. So I'm actually going to do this right in the key code example. So let's draw something else. Let's leave the background as it is. So another way I can do this is I can say, let's say compound and. I can say if key is pressed. And to do an and in JavaScript and a few other languages, I use two ampersands. This is a shortcut for and. So two ampersands, if key is pressed and, let's say the key code equals, let's use keycode.info. I'm going to draw a rectangle. So that would be the R key, so that's 82. So if the key code equals 82, then let's draw a rectangle. I'm just going to draw it in the middle of the canvas. And so let's see. So now I have one condition for drawing the background, but I have another condition, R, there's my rectangle. And actually, let's draw it. Let's say rect mode is center so we can see the whole thing. So if I'm pressing a key and the key code is 82, now we get this nice rectangle in the center of our sketch. I can also use or. So let's do this one. So we'll say compound or. So let's say if the key code equals, let's do C, so 67 for circle, or, and it might be an ellipse, a circle or an ellipse, so we can use 69 for E. So if the key code equals 67 or the key code equals 69, and this might be confusing, so I'll probably want to put a comment here. So I'll say key is R, and here I'll say key is C or E. So if I hit C or E, let's draw a circle. So I'll draw an ellipse at 200, 200, 200. Okay, so now if I hit C, there's a circle, E, there's a circle, and R, there's a rectangle. And I'm not using key as pressed down here because I'm using this or statement, so the circle stays. So I could actually make this even crazier. I could put this compound section into parentheses to make one group and say key is pressed and then I have an or here, so it's either or, so C or E. But that's probably going overboard. And I actually screwed this up. Oh, I misspelled pressed. So C, E, R, space. So that might be a little too confusing. Let's get rid of that for now. But you can group these things together and make even more complicated conditionals. So the advantage of a compound is that we just have one line versus nested, we have two lines. The advantage of nested is that if we have a bunch of stuff that is going to happen for key is pressed, we can just do one if key is pressed and then do a bunch of stuff in here versus using key is pressed every time we want to evaluate a condition. So I think that's it. Yeah, that's the last bit I wanted to go over. So this stuff that gets more complicated, you may not really need to use, especially for the first bit of this assignment. But it might be useful if you're trying to do something very specific. If you're not sure, just ask me and tell me what you're trying to do, and we can go over it. S Go ahead. Yeah, that's kind of what I did the last bit. So that's what I would do here. Let's do another example. So let's say compound and mhm. you, yeah, you could. I mean, at that point, it becomes sort of like a preference situation of like, do you want some really crazy long if statement or do you want to simplify it? So let's say I want to do and plus or. Um, so I could do if mouse is pressed and key is pressed. Or no, you said this is a or. So, or key is pressed. Okay, so that's kind of simple. So if the key is pressed or the mouse is pressed, let's in that case, let's do something new. Let's draw, or let's just cover everything up. Let's say, or no, we'll lose all this other crap. So let's just do um, what else can we draw? Let's just change the fill to purple, and then we'll draw a same circle. Let's just grab this circle and put it down here. Okay, so if the mouse is pressed or the key is pressed, we'll get a purple circle. So pretty much anything I do in this case, we get a little purple circle on the screen. Um, However, if we want to change this so we know what key it is, then we can make this its own group. So I can put parentheses around key is pressed and then say and key code equals 32 for space. And so now I only get the purple ellipse with space, whereas like, uh, well, I still get the purple. What? Yeah. Yeah, just like any math equation that you might do, like if I was doing some basic math, I might say something like, 5 plus 2 times 10. That's going to give me 25 because it's going to do 2 times 10 first, but I might want to do 5 plus 2 first. So I could say parentheses 5 plus 2 and then times 10. And so yeah, you can do basic grouping just like you would do in math. Um, so that's one way you could do it. Some people might not like this because this is super long, or for other reasons. So another way you could do this is say if mouse is pressed, you could use a nested approach. You could say if mouse is pressed, then if key is pressed and key code equals 32, then let's do something similar but slightly different. Although this is the same condition, so it doesn't really matter. Let's do yellow. Oh, I guess I got something wrong. Fill yellow ellipse. Yeah, okay, that's actually a good point. I didn't think through that all the way. You're right. So I have to be hitting mouse and hitting space for this. So actually, this is not an equivalent example. I actually don't know if there is a way. Sorry? Yeah, no, it's a good thing to go over. I mean, there's a point at which there's like endless variations of if statements that you could clarify. But yeah, that's a good thing to go over is that actually this compound situation does have an advantage over this nested situation where I can make this the same would be if it's an and, then it would have to be the same. Where it's different is if this is an or. If this is an or, then it gives me uh, different options. So yeah, let's get rid of this one. Um, yeah, that's a good thing to clarify. Let's go back to the week for a second. So any other questions you guys want to go over? All right, so let me stop the